Okay, now that we have some idea of how to run a hypothesis test for a mean, let's take a look at some examples here. So let's look at a setup first, just looking at the test statistic, that piece here that calculated the test statistic, which is step number 4, right? Once you have the null alternative and then you have the sample data, and we know we're running a left tail test here, it's a less than symbol. You would calculate the test statistic. And then after you calculate the test statistic, again, you're just substituting into this equation here and you get a value. And then what needs to happen is you would then calculate the probability of observing this test statistic or something more extreme. So in this case, that t is less than or equal to negative 2.67. It's a left tail test, and so we would use StatCrunch. And again, you got to be careful with the rounding. If you round earlier, then your values would be off just a little bit. So just make sure you got a sense of the value, right, and where you round. It's always best to round at the end. And so once you have your t calculator, the degrees of freedom, we got to go back to look at that. What's the probability? In this case, your n was 16, so your degrees of freedom would be 15, and it's negative 2. It was 16. Oh, let me double check. 15. Yeah, 15. And then it's less than negative 2.67, the probability. And it's a test t calculator, so it's the test, even though it says x, if we're talking about t. And so then you get the probability is 0.009. And so that's what we would have, probably 0.009 here. Okay. Would be your probability here. And then we do the same thing here. Yeah, this is a two-tail test. You'd calculate your values and plug them in, and then we're going to use the t calculator. Now, it's a two-tail test, right? So we talked about that we would then have to calculate two probabilities, the left tail and the right tail, for 1.77. So we can do those separately, or just do it for 1 and then multiply by 2, which is not what we're going to do. Either way, you can do them in 2 steps, or I'm going to do it in 1 step because it's symmetric, the t distribution. We just need to do 1 and then multiply by 2. So your n is 50, so your degrees of freedom will be 49. And then I'm going to do greater than or equal to 1.77. And so you see we get a p-value of 0.041. 0.041 is what we get for this one here, right? Right here, this equals 0.041. And then if we do this one, this would also equal to 0.041. So what you can do is just multiply it by 2 there. 0.2 times 0.041. And so then you get 0.082. That would be your probability. Your in this case, that would be your p-value, the probability of observing this test statistic in this two-tail test scenario there. Okay, so let's look at a full example here. Looking at this setup here, back to this running situation. We knew the null and alternative. The mean was 30 minutes, and the alternative was less than 30 minutes. We had some sample data here. And then we're basically asking again, we're wondering, is this sample data, right? Is this enough evidence to reject the null hypothesis, right? That's what we're thinking about. There is no alpha level stated, and so we're going to assume an alpha level of 0.05. That will be our alpha level. And then we go through the steps. So one sample t-test, is it independent, random, large enough? Right, so we would assume 20 is less than 5% of all the participants. Let's see, the run times for the participants. It doesn't say it was randomly selected, so it's not clear, okay, and that it's random. But again, we want to assume, but we would have to be very skeptical or very cautious about the results if we don't know this data was collected randomly. And it was a sample large enough. It's not greater than 30. And so we're not sure about the distribution of the population. So since these requirements are not met, we will proceed with caution, meaning that we'll do the calculations, but we're not sure that we've met the requirements. So we're going to have to be very cautious, or have to get some more information about that data and how it was collected. Furthermore, then we would look at, once we have that, again, we ideally would want the conditions to be met. Step 4 would be to do the test statistic. Again, you substitute into these values here. You will get negative 0.039. If we're rounding, if you don't round, you'll get negative 0.631. Either way, what we see is, in this case here, we have a test statistic, and so we're going to test the, we got to get the p-value, that it's less than negative 0.639. 639 less than, and our degrees of freedom, n was 20, so this would be 19, compute, and so I get a p-value of 0.265. 0.265 here, 0.265, and since 0.265 is greater than, since this p-value is greater than alpha, 5%, right, the probability of observing that is not low, right, 26%. We failed to reject the null hypothesis. We failed to reject. So what I like to do is make a note of that. We do not reject that, and we're rejecting that. And so our conclusion is there is not sufficient, or there is insufficient or not sufficient evidence to conclude that the mean run time for all participants is less than 30 minutes. But we still have to be cautious again because of the requirements weren't met.